So, with this new series called the Innovator Spotlight, our goal is to showcase what teachers and innovators are doing in the classroom that's real, that's practical, that's applied, share what works in a way so that you have something that you can use tomorrow. That said, I want to introduce our speaker for this month. It's Matt Wilkins. He is here representing a Galactic Polymath Education Studio. He's a former teacher, he's also a scientist. So I am going to let him talk a little bit more about what he does. And so with that, I will pass it on to you. Thank you.
Well, hi everyone, all over the globe. Thanks so much to Michelle and the Earth Prize for inviting me to speak. And thanks to all of you for showing up at a weird time of night. Sounds like a lot of you, it's early in the morning or late at night. So appreciate you being here. It means a lot. So I'm going to talk about Galactic Polymath. I'm based out of Minneapolis, Minnesota, right now in the US. But I founded this back when I was in Nashville, Tennessee. And the idea behind this project is kind of what Michelle was alluding to at the beginning. It's sort of like, what is possible, right? Like, why is it that when what we learn in the classroom is so divorced from like the cutting edge and the authentic reality of science in the classroom? And why, so as a practicing scientist, like, why was it so hard to connect to a K-12 classroom where every member of society goes through an important part of their life to learn about the world and how they fit into it. And why do we turn away so many people from seeing STEM and science as part of their lives? So, the idea behind this whole effort is to think about what is possible, and hopefully, I will show you what we've been doing for the last 5 years so that it can help you connect with your students in kind of new ways. So my background is as a biologist. I studied birdsong evolution for my PhD research. Um, and during the course of this period, I became kind of really frustrated with, again, the lack of connections between the academic world and what we're knowing about, the universe. I mean, there are like an estimated 2.5 million scientific papers published every year now, and such a diminishingly small fraction of those actually connect with the public in any meaningful way. And it's a disservice to both the scientists and the public funds that are used to generate that research. And so I became really fascinated with trying to bridge this gap between academia and mobilize knowledge out of the ivory tower into classrooms where it really matters and can connect with students. Um, and so that basically led me on a big career pivot to try to understand K-12 and why this bridge is so broken and like kind of what are the unique challenges for connecting in the K-12 sphere, especially in the United States, where we've seen a lot of kind of fragmentation of education efforts and defunding of public education in general, and the privatization of ed tech and the massive growth in ed tech and the kind of modern you know paywalls that we put in front of knowledge so that like rich kids get a great education and poor kids don't have access to the same opportunities. So I took this unique position with Vanderbilt where I was a resident scientist at a middle school for 3.5 years. And then I taught for another year, I taught biology to seventh graders at a homeschool tutorial. And this was some of the most meaningful years of my life, honestly. But it was incredibly impactful in terms of what I learned about, what challenges teachers are facing and how the kind of outreach materials that scientists are generating are not connecting with them. Um, and so it led me to found Galactic Polymath, which is not a math company. It's about polymath. So it's an education studio that translates complex scientific research to make science matter for the next generation of students. And so Galactic is meant to give students the bigger picture of systems thinking, like what are we doing here? How do we fit into this? How do all the pieces of a system fit together? And polymath is a creative interdisciplinary problem solver like Da Vinci or Hedy Lamarr. And so we want to provide more of an authentic approach to science that is interdisciplinary. All real world problems are interdisciplinary. You need people working together across, the traditionally siloed subjects. You cannot have science without historical context and culture. Social studies, you cannot have it in isolation without being able to communicate it through language, and science doesn't work without math. So you need everything connected, and yet a lot of the curriculum that's available doesn't convey things that way. It's a bunch of kind of disparate factoids, and students are left asking, why are we learning this? Or like, how is this connected to the real world? Everything this company has produced over the last 5 years is an answer to that. Like students will not ask that question because we spend a lot of time embedding these in real research and real storylines, the human experience of science and the sense of discovery. And we give students the opportunity to play with real data that's ripped directly from current papers. So we've helped scientists around the world translate their research into open access lessons and videos for grades 6 through plus. So these are free to you because mostly the National Science Foundation has paid for it. So we're about to release our 21st unit. So each one of these mini units connects with a different body of research that is related to the research group. Um, they're about 3 to 6 lessons. They've been developed with hundreds of hours over periods of months with scientists, teachers, artists, and filmmakers. So we want to make it beautiful. We want to embed it in authentic science. We want to have students connect to data literacy because information in the information age, data literacy is literacy. And we all need that to be able to make informed decisions in our lives. Um, and so these units you can get them directly at galacticpolymath.com. We have a separate, that's kind of a Squarespace site. You'll find the actual units are at a subdomain, uh, but it's all connected, so you won't get lost. But these are meant to be comprehensive learning experiences that a non-specialist can teach. So you shouldn't need a master's to teach any of these units, even though they connect with current research and authentic science. So we spend a lot of time developing videos. I'm going to show you a few examples that make these easy to run, highly engaging, and kind of showcase scientific thinking and the personalities of diverse kind of role models, and how they think about real world problems. So again, these are free. So I'll just start with our example of side journeys. So this is a unit we developed with Jocelyn Bosley at University of Nebraska. She's like a champion of science. She's one of the best advocates we have for science, who works with a bunch of scientists, materials research. And she brought together a number of the if then she can advocates. So these are representatives for the Lyda Hill Foundation, showcasing women in science. And so we brought them in to share their stories and how they connect to the scientific process. So we'll start with Rose Bear Don't Walk. Uh, she is kind of, each one is the foundation of a different step in the scientific method, and they each kind of talk about their own kind of personal journey um, and their connection to asking questions, developing hypotheses, and running experiments and testing methods. Um, so I'm just going to give you the kind of trailer that kind of summarizes all of this.
Stand back! I'm going to try science! What do you picture in your mind when you hear that? Someone mixing flasks of mysterious liquids or dissecting a cow's eye?
Brother, ugh.
Whatever you pictured, I bet it was an action. Maybe you even thought about the scientific method. But reducing science to a single method is kind of like saying music is just a sequence of notes. Science is more than a single method. It's a whole bunch of methods. Practicing scientists blend, remix, skip, and repeat steps as they make exciting new discoveries about our universe. Science is a journey. In this unit, you will practice asking questions, generating hypotheses, and planning your own study as you follow the journeys of real scientists. You'll find that science is as much about doing as knowing. It's filled with challenges and unexpected twists. Successful scientists are those who develop the resilience and creativity to transform obstacles into opportunities. Get ready to unlock your unique science superpowers as you embark on your own sci journey.
So this unit has 3 different lessons. These are meant to kind of plug and play into your existing curriculum. So if you're teaching about if you're teaching the scientific method, this is a great resource to begin or end that unit, to kind of introduce the kind of like excitement and personal journeys and personal stories connected to these different, they're vastly different areas of research. looking at ethnobotany, biomechanical engineering, and cryoseismology, glaciology. You know, so each one of these has a video with each of the focal scientists being featured, and they connect to some, student-driven activities. So like where they're practicing their own, skills of inquiry and so forth. And it's all centered around the side journeys, reframing of the scientific method. We spent at least a month, maybe a month and a half, just developing this framework and thinking about how do we visually represent a more authentic scientific process that's not just step one, then step two, step three, because it ain't like that when scientists are actually doing, research. You're asking questions is constantly informed by the new data coming in, previous analysis, and the thing that I've never seen in other frameworks about the scientific method is that we put communication at the center, because as soon as you ask a question, you communicate that to whether it's your PhD advisor, committee members, or others in your community, and you get feedback. You'll revise those questions before you go on to like forming hypotheses or collecting data. So this framework is general and it could be used, throughout a unit. You'll find that a lot of the stuff that we developed, there's a framework underlying it because we really want to move away from students having these kind of, bombardments with facts and stuff. We want them to have a framework to put this information into so that they have more durable, lasting understanding of a topic. So next I'll move to data streams. This is a unit we developed with Dr. Tom Luring at Wichita State, and features two of his current grad students and a former grad student who's now gone on to be a field biologist. And I'll just show you the trailer for this one that previously there were two free lessons. We just released a third one that goes a bit deeper and connects to a current research study that's connected to how wetting and redrying cycles and climate change interact to affect amphibian populations.
In the information age, where we are constantly bombarded with charts, graphs, and claims about what they say, data literacy means success. In Data Streams, a crash course in data literacy using stream ecology, your students will gain tools, experience, and confidence to make sense of graphs in daily life. With 2 interactive and engaging lessons, this unit is standards aligned and ready for high school to college. Psst! Here's the secret at the center of this unit. It's a framework for data literacy we developed to help students make sense of any figure. The supporting videos walk students through the steps to systematically extract meaning from different types of graphs.
Ask yourself, what patterns do I see? What do the text prompts tell me? Is there anything strange, like outlier points, missing data, or weird scales of measurements? What's the takeaway? And do you trust it? Is there anything such as a questionable or unknown source that makes you doubt the takeaway?
Students will practice the PST approach as they explore data on how word frequencies in books change over time, and synthesize information in figures, tables, and maps to deepen understanding of stream flow data. This unit is all about building student interest and confidence in analyzing data. Along the way, students will see scientists model how to use the PST method to make sense of graphs.
Right over here, it's kind of interesting that there's no graph in this region either.
Our units start with strongly student-centered activities that grow curiosity and engagement as lessons become more centered on authentic research and data. By teaching this unit, you will introduce your students to the fun, challenging, and creative world of data science, and equip them with new skills to inform the decisions they make on a daily basis. The best part? This unit is completely free and editable, thanks to Dr. Luring's lab at Wichita State University.
So this unit, it seems like we're tackling something completely different in lesson one. And we did that by design. So we developed this framework, the PPSTT framework, because we saw that when you do mathematical operations, you have PEMDAS, right? So we know we have the order of operations. We know that, first you look at the parentheses, then you look at the exponents and so forth. There's no equivalent that we found for making sense of a graph, even though this is something we daily work on, and there's a lot of efforts about data literacy out there. So what we wanted to do is help students think like scientists to make sense of basically any graph in a stepwise fashion. And so that's where this is. And we wanted the introductory example of that to be flexible. So if you take nothing else from this unit, if you're not teaching about ecology or you don't want to talk about like water or how it's connected to climate change or amphibian populations, you can just grab the first lesson of this and use it in any classroom that touches data literacy on any topic. And it uses the Ngram. Can anybody just drop in the chat whether you've used the Ngram viewer, if you're aware of this tool, or if you have any idea what I'm talking about? Yeah, it's kind of one of the least well-known like data literacy tools that exist, I think. If you just type in Ngram viewer, it's an amazing chance. So this is also, we want to teach students how to fish, right? Teach them things. Sorry, let me just can pull up the link probably. We want to teach students how to fish when it comes to data. So we'll be introducing them to different tools that they can use for the rest of their lives. We want to kind of like open up new opportunities, and Ngram viewer is one of them.
I can snag that while you keep going.
Yeah, I just got it. So here's the link to that. It basically, Google has millions of books that they've scanned. And so you can actually look at the frequency of word usage over time. And so you can type in things like superstition or witchcraft and type in science and see how those curves change over time. Like as witchcraft goes down, science goes up. And it's great. It's a really thought-provoking activity that's connected directly to data literacy and having students think creatively about data literacy. So that's why we used it to introduce this framework. All right, so moving on. Bioinspired was a unit that we developed with Emily Snell-Rude's group. She's an evolutionary biologist at University of Minnesota, but she worked with a working group that's biologists, designers, engineers, and architects. And they're just interested in helping students and the general public better understand how evolutionary biology can be used as inspiration for solving modern day challenges, whether it's sustainability or just like practical design or, life cycle of things. So I'll just show you the intro video to that.
What do bullet trains and waterproof clothing have in common? Recent advances in both were inspired by biology. Though high-speed trains are only getting started in the US, they have been transporting people at speeds over 160 miles per hour for decades around the world. Early designs were quite noisy, particularly when leaving a tunnel. To make the Japanese Shinkansen train quieter, lead engineer Eiji Nagatsu looked to the Kingfisher for inspiration. By elongating the train nose to match the shape of the Kingfisher's beak, Nagatsu's team created a train that goes 10 times faster, uses 15% less energy, and produces significantly less noise. A seemingly unrelated problem has to do with waterproof clothing. Pretty much every waterproof fabric on the market today relies on a coating, such as PFCs and other harmful chemicals, that eventually rub off and pollute the environment. To solve this problem, Amphico founder Jun Kimei researched how insects stay dry. Using nanofabrication techniques to mimic the structure of insect exoskeletons, Kimei's team created a fabric that's inherently waterproof. There's no coating to rub off, it's 100% recyclable, and it doesn't pollute the environment. But why are these stories so unusual? In our drive to produce inexpensive solutions for billions of people, sometimes what we create is deeply flawed. On top of that, we might start with a big innovative leap like this, but then we end up getting stuck on a design plateau. One way to break out of this mold is to look to biology for inspiration. This concept isn't new though. Many great inventors have been inspired by nature throughout history, but modern-day scientists, engineers, and designers are increasingly looking to biology for innovating solutions. So, why is biology such a valuable source of design inspiration?
Life has existed on Earth for over 3 billion years. During this vast span of time, organisms have evolved and diversified. There are over 2 million described species on Earth and possibly up to 30 million total. There are about 500,000 beetles alone and over 1 million described insects, each with thousands of genes and hundreds of traits. That's an awful lot of biological information to draw from. This can result in really creative and unexpected solutions to a wide range of problems. So our research group is asking, how can we use biology to create better designs?
In this video series, we'll walk you through how to use the 5-step Bioinspired Design process. Here's how it works. The first step is to define the problem you want to solve. Then, biologize the problem. Here, we want to translate the function we're looking for into a biological example that performs the same function in nature. After some background research, you should come up with a short list of organisms that perform the desired functions. Now it's time for step 3. Select a biological model. At this point, you should analyze the pros and cons of each organism, then select one organism's specific trait to use as your design inspiration. Next is step 4, propose a solution. This step is about putting your idea into action. Make a presentation, write a paper, or build a prototype. Once you get your idea out there, you're ready for step 5, evaluate. Gather feedback, test your design, and iterate. You might even circle back to an earlier step to further develop your idea. If you're ready to get bio-inspired, watch the next video to get started. Your creativity can help solve big world problems or bring joy to someone else's life.
So this unit really lends itself to a project. So it's actually been used in both high school classrooms, college classrooms, and middle school. So it's a very flexible framework. The videos are mainly support lessons 1 through 3. We kind of didn't win the grant follow-up that we wanted to be able to like fully support the other units, the other parts that are they get more and more complicated the further you get down. But really, I think just having students identify a problem and think creatively about what are the solutions and do some research to discover cool adaptations that might inform redesigns. We've had students like 7th graders come up with like, what if we had like a washcloth that was modeled after a cat's tongue to like exfoliate the skin? I mean, it's really a fun unit. But it centers around this framework, which again, we worked with that whole team for months to settle on this. So I think it's a great guide for the creative process. The last one I'll give you is future foods. So this was a unit we worked again with the University of Nebraska, but it's a highly interdisciplinary, interinstitutional unit working where it's based on a working group, the Food ID Global Center, which is funded by the National Science Foundation in partnership with Finland. So it's really cool. I'll just give you a couple of examples here. So this one is trying to have, I'll just let the video speak for itself.
Have you ever thought about how the food we eat contributes to a warming planet?
Recent studies suggest that food systems are responsible for 1/3 of global human-caused greenhouse gas emissions. So it's super important to know how the food in our plates affect the climate. For example, my favorite food is an arepa. It's a corn flatbread pocket, and in my case, stuffed with chicken, cheese, and avocado. When I buy these ingredients from the supermarket, I generally have no clue about where they came from or what went into making them. And unlike nutrition labels, companies aren't required to report anything about the carbon footprint of their products.
Since we don't have that information, the best we can do is come up with a spidey sense for what types of food release greenhouse gases during their production and why.
Fortunately, resources like ourworldandData.org can help us hone in our carbon footprint spidey sense. Researchers at the University of Oxford run this website, and they make it easy to explore estimated greenhouse gas emissions associated with everyday foods. After checking out the website, linked below in the description by the way, ask yourself, what ingredient dominates the carbon footprint of your favorite dish? Our World in Data can take our curiosity one step further by showing us where in the production process greenhouse gases are released. They break things down by how much carbon is released by land use change through deforestation or disturbing the soil, emissions from cow farts and crop fertilizers, burning fuel to grow and process animal feed, energy used to process raw foods, transporting foods to markets, refrigeration at shops, packaging materials, and excess emissions because of food waste and loss during each step of production. This might look overwhelming, but it's worth sitting with the data, and resources like Our World in Data can help us make informed choices. For the time being, it's important to consider how our eating habits over our lifetime is going to impact the planet. For example, can we swap out or remove an ingredient from our favorite dish to significantly reduce its carbon footprint? Like substituting a cheeseburger with a turkey burger. Would that be an acceptable substitute? We can also think about the future of our food. Scientists are working on ways to produce cheaper, more sustainable sources of protein from mushrooms, insects, plants, and cultivated meat. How will these new food affect our carbon footprint? Before I finish my favorite dish, I'm curious to learn about your favorite food. What factors contribute to its carbon footprint, and what a more sustainable version of it will look like and taste like in 20 years? Do you have a taste for this topic? This video supports free lessons from our Future Foods unit. Check it out, link in the description.
So this is a 4-lesson unit that it's really focused on students, right? So we want to ask them what is their favorite food. So we're going to get investment and have them share what it is and what it means to them, and then use that as a way in to get them curious about looking at their carbon footprints, and kind of layering onto that. So like what drives the carbon footprint of your food, and how is that specifically accumulated during the farm to table process. So getting them to think critically. And lesson 2 introduces this kind of fun little game, which it can also be used. It could just be used by itself if you're doing something different. But it's a fun game show to like test students' knowledge of carbon footprints.
Welcome to Carbon Kitchen, the game show where you can test your knowledge on the carbon footprint of foods. In our previous video, we introduced you to Our World in Data as a resource to develop our spidey senses. Now, let's put them to the test. First up, cheese pizza. Which of these key ingredients release the most greenhouse gases during production? Is it wheat, cheese, or tomatoes? The answer is tomato. No, just kidding, it's cheese. Next up, we have cheeseburger. No mayo, no tomatoes. What's the biggest climate warming ingredient? Is it wheat, cheese, beef, or lettuce? The answer is beef. That's what the data tells us. Next up, we have chocolate chip cookies. Here, we have wheat, egg, butter, chocolate, and sugar. Which one of these has the highest carbon footprint? Marcy, what's the answer? She said it was chocolate. All right, friends, bonus round. Don't get too excited. You're loading up a taco. Pick the protein with the lowest carbon footprint. Is it shrimp? Answer is chicken. That's pretty surprising. I thought it was going to be like shrimp or something like that, but it's chicken. Well, friends, that's our game. Thanks for playing Carbon Kitchen. If you want to know more about where this data came from and how you can explore it on your own.
So that video is interwoven into the presentation, so we can have students like actually diving into the materials, so they have like data that they're looking at in tables and graphs to try to like have an informed question and kind of like get into like, oh, I want to get the question right. And then this leads to lesson 4, where we actually dive into current research with this group is doing to make foods more sustainable, so that like we're kind of limited in what our options are right now. If you want to keep eating high, if you need a protein source, like there's not a lot of sustainable and affordable options. So just one more thing, and then we can turn it to questions. But I wanted to draw your attention to JobViz. So this is a free resource that you can use to basically, from grade 6 to adult, explore the true diversity of career opportunities. This was actually a project that I started as a postdoc, using publicly available data, but it lets you explore 800 plus careers that most of which students will have never heard of, and look at what's the median wage, what's the expected growth in the next 10 years. And we also just recently launched the ability for teachers to create tours. So you can do kind of a custom job tour if you wanted to show like medical professions you've never heard of that pay well with a bachelor's degree, stuff like that. Because we only know what our parents do and what, a few people in our personal experience do, usually are on TV. And it's such a diminishingly small, proportion of the actual diversity of careers out there. So check it out. The units are also connected directly to this, along with growth data. And I'll leave it there. And thank you so much for your time and for staying up late to be here with me.